So far, a lot of the convergence tests that we've looked at require the series to look a particular way. Maybe it has to be in a particular form, or it has to look like another series so that you can compare it. There are some tests that work without those kinds of requirements though, thankfully. Today, we're going to be looking at the ratio and root tests. Let's look at the ratio test first. As you might imagine, we're testing the series with a ratio again. This time, however, the ratio is with itself. Okay, so here's the whole test written out. Don't worry, we'll break it down. First, take the sequence and replace n with n plus 1. Then, divide it by the original version. Shove that fraction into an absolute value, and then take the limit of that to infinity. You'll get some kind of number, we'll call it L for now. If that number is less than 1, the whole series is convergent. If it's greater than 1, divergent. However, if the number is exactly equal to 1, bad news, the test tells us nothing. It fails. Gotta try something else. Alright, so that's a lot of detail, so let's actually try that on an actual problem real quick. Let's see if this series is convergent. Remember to pause if you need to read something more closely. Alright, so a couple of things to note. Often, when your sequence itself is a fraction, we skip straight to the multiplying by the reciprocal step, so watch out for that. Also, make sure to look for opportunities to evaluate the absolute value. A lot of times, its contents are always positive anyways, so you can just get rid of it, but make sure to check. Another thing, the ratio test is often useful if there are factors that cancel with themselves really easily. Most notably, this includes exponential factors and factorials. The presence of those is a good hint that the ratio test might be useful. That's the ratio test. Now let's look at the root test. It's actually really similar. Again, we're making a calculation with the sequence inside of a limit. This time, the sequence is inside of an absolute value, and then nth rooted. Now, an nth root is kind of weird, but remember that it's the same thing as a power of 1 over n. Again, you take the limit as n approaches infinity, and again, you compare that value to 1. If the value of the limit is less than 1, it's convergent. Greater than 1, divergent. Works the exact same way. Why don't we try this one too? Let's try it on this series. We're putting infinity in the greater than category for the root test, so this is divergent. The root test is most useful when you have an exponent that needs a root. Usually, this is when your entire sequence has some sort of power of n, or a function of n. We just released a small set of videos about convergence tests, so give those a watch if you want to learn about more of them. Thanks for watching, bye!